So if you recall yesterday, we did the reading. In your class, we only got to do the longitude so far. What we haven't done is the miscellaneous for the longitude, and we haven't done latitude at all yet. Again, this is as far as we got yesterday. So if you don't, I think we were rushing out at the bottom here. So we did get 180 was the international date line. And we're gonna go ahead and we're gonna start right up with the latitude side now. So we're gonna do the same thing. Oh, I did forget that we needed highlighters here. I'll hand them out real quick. So we're gonna do the same ideas we did yesterday. We're gonna do the same ideas we did yesterday. We're going to read the reading, highlight the name of 0 degrees, highlight what the names are or lines are called, highlight which way they run. You're gonna highlight which way they measure or what they measure, and you're gonna highlight the highest degree. Are we ready for this? Yes, sir. I don't think that was plugged in. There you go.
No.
All right. So again, get your highlighters ready. And we're gonna do latitude. Ready? It says latitude is the distance in degrees north or south of the equator. The equator is 0 degrees latitude, while the North Pole is 90 degrees latitude and the South Pole is 90 degrees south latitude. The reference point for determining a person's latitude is the equator. If you draw a line from the equator to the center of the earth, and then from the center of the earth to where a person is, the angle between the two lines determines the person's latitude. For example, the angle formed between the line drawn from the equator to the center of the earth and the line from the center of the earth to a location in New York State would be 42 degrees. This means that the latitude of that location in New York State is 42 degrees north. All points are the same angular distance from the equator and have the same latitude and lie on a circle called parallels of latitude. These imaginary lines circle the earth in an east-west direction, parallel to the equator. On a map, these lines are horizontal. Degrees of latitude are about 111.1 kilometers from each other. I'm just going to read part of the measuring of the latitude, just the first paragraph. At night in the northern hemisphere, latitude can be determined by measuring the altitude of Polaris. The altitude of Polaris is equal to the observer's latitude. Polaris is not visible in the southern hemisphere, so altitudes of other stars must be measured to determine the latitude. So again, you are looking for, where is 0 degrees? Give me a name. Oh, okay, so we're just gonna do it. All right, let's just do it. 0 degrees is the equator. And what are lines of latitude really called? What are they? Parallels of latitude, yep. Parallels of latitude. Hey, quick side note, why do you think they're called parallels of latitude? Because the lines are parallel. Look how these lines go across the earth and they never touch any other lines. Why don't we call longitude lines parallel? They do, they all touch at the North Pole. Which way do these lines go? They do go side to side. Yes, or east to west, but just like yesterday, I don't want to talk about that. So we can, horizontal. And again, what do those look like? Those are nice flat lines. Guys, I like to think of latitude. I always say in my head, latitude, flatitude, because there's a flat across lines. That's just what I go with, so I don't forget. So again, when you look at them, you can see they don't touch. They do circle around the North Pole. What do these lines measure? Degrees of what? Degrees north or degrees south of the equator. And did you catch the highest degree? Yep. 90 degrees north and 90 degrees south. By the way, what's the name of the place at 90 degrees north? North Pole.
North Pole.
You got it. Add that in too. That is everything you got to know about the basics of latitude and longitude. It's a couple miscellaneous things. What do you think that miscellaneous thing is going to be for latitude that I haven't talked about yet in the notes, what we just read about it? Take a look at the picture. Something about stars. What about the Big Dipper? What did it say in the reading? Okay, hang on. What did it say in the reading? About something about stars. It did. Specifically a star named Polaris. We need altitude of Polaris equals your latitude. So first of all, we got to know what Polaris is. Does anybody know what Polaris is? It's a fancy name for a certain star. It is the North Star. So I'm going to add that right underneath it. Can't see? Okay. Sorry, we're tangled. All right, altitude of Polaris equals your latitude. By the way, Polaris is the North Star. What do you guys know about the North Star? You should know a little bit. It can help what? It can help with a compass. Who used the North Star? Okay, all of those people did. Mary did go. Okay, absolutely. I was huh? Oh, probably. I was gonna go with and all of those are true. You guys are all right. The one I was gonna go with is when slaves were using the Underground Railroad. Do you guys remember that from social studies? When where were they going when they were escaping slavery? Where were they headed? No, they didn't actually go underground on the Underground Railroad, for the record. Where were they headed? Up north. How do you think the North Star helped them? They followed the North Star and it led them north. Okay, it is called the North Star. There's a couple reasons for this. Have you also heard if you follow the North Star, like if you're lost in the woods, just follow the North Star and you'll be unlost? Oh, I got you, Sarah. Got you, Sarah. Sarah says, well, which one's the North Star? And I'm not gonna lie, everybody had that same problem. So the slaves escaping slavery probably looked at the sky and they're like, well, what the heck, which one's the North Star? So there's a couple things going on. I want to take it a couple steps back. Well, how does the North Star lead you north? And because, well, it is called the North Star, but why? Yeah, Keith, do you know? Well, then we're out of luck, but that's a whole one of those what ifs that we don't want to talk about. Friday after school, 3 to 5. So here's a globe. You guys have all at least looked at the stars once, right? So you know they're kind of like a ceiling above the earth. Huh? A black ceiling with polka dots on it. Yep. So we're gonna take this simple. We're gonna get to more stars later in the year, but the basics of it. So the stars are a lot like the ceiling. The stars throughout the night, the stars themselves don't move. The stars hold still. But it looks like they move. Most of the stars look like they move. If I just said they're holding still, how can they look like they're moving? Because the earth is moving. So the earth is spinning. And I want to demonstrate this to you guys real quick. Could y'all stand up for just a second? And what I want you to do is I want you to find something that you can line yourself up with on the ceiling. So I'm going to go with the corner of this light. So you might be able to line yourself up with a speaker or a fire alarm thingy, or if you can't, just find a cross where the tiles kind of just meet. And do your best to line yourself up with one of them. And what I want you to do is focus in on that spot and do one full turn underneath it. Yeah, try not to make yourself dizzy. Just one turn, because I don't want anybody getting dizzy. So how did the rest of the room look while you turned? Spinning. It looked like it was spinning. Okay, so when I did this, it looked like the whole room was spinning. In truth, was the ceiling spinning? No. You were spinning. But I wanted you to focus on one thing. So if I focused on this and turned, and especially since I'm lined right up with it, actually because I'm lined right up with it, what happens to this thing? Does it look like it's moving? Okay, it shouldn't. So why don't you do that one more time, lining yourself up perfectly with something and just stare at that one thing. Okay, you don't want to? Okay, that works too. So Sarah, did you kind of see it? Yeah. Where that one thing looked like it held still, but everything else moved around? Yeah. Okay, yes. Hopefully nobody's ill. Sit back down. That's what the North Star does. The North Star actually lives right above the North Pole. So because that's where we're spinning is from the North Pole and the North Star lives here, it looks like it never moves throughout the day, just like this projector didn't move for me. But the rest of the ceiling looked like it was moving, right? And that's the rest of the stars. So the North Star is helpful because it's the only star in the sky that doesn't look like it moves at all from 1 hour to the next. That's why people are able to use the North Star to help them, because it's the only one not moving. If you were trying to follow a star that was moving, you're just going to end up walking in a big circle. But because the North Star doesn't move, we can use it to help us in our navigation. Yeah, Keith. Okay, I'm going to keep going. So when they say to use that, if you're lost in the woods and use the North Star to find your way home, it'll kind of work if your house is north of where you're going. But what it does, and what it did for the slaves, is if those slaves kept the North Star lined up with them as they walked through the woods, what it did was it guaranteed they were walking in a straight line north. It didn't necessarily, it wouldn't get you to my house because my house is not north of here. But at least I would be walking in a straight line and would hopefully be getting somewhere where then I could find out where exactly I am. That's how they say it can help you get out of the woods. It won't necessarily help you find your house, but it'll help you not walk in a circle all night long. Yeah, figure out. No, well, you can't see it during the day. Certainly slaves didn't have one that they could. I don't think we have there are any household ones good enough. Yes, if you had the Hubble Space Telescope or one of those really expensive ones that have an observatory, maybe. But then I'm guessing they don't want. But anyway, then Sarah's problem is, what was your problem with this whole situation, Sarah? There's 17,000 stars and I can't find it. How the heck am I going to find the North Star? You look up. Okay, so would it be helpful if the North Star was the brightest star? Yeah, it's not. Would it be helpful if the North Star was the first star that came out in the day at night? Yeah, it's not. Would it be helpful if it had a big arrow pointing to it that said North Star? Yeah, and it actually kind of does. There is kind of like an arrow pointing to the North Star. Now, I'm going to assume you guys have at some point looked for constellations, maybe. If you haven't, maybe you've been a little sheltered, maybe you lead a boring life and you don't ever have a campfire at nighttime, and that's okay. It's supposed to eventually stop raining one of these days, and I would like you, obviously it's not really homework, but if you're outside and it's dark out and it's halfway nice out and you can see stars, I do want you to take a look, if you can remember, to just look up. Have you ever seen the Big Dipper? Okay, so Sarah, this is your homework. So the Big Dipper is a fairly easy constellation to see. It's okay, easy-ish. Here's what the Big Dipper looks like. So do you guys know what a dipper is? Let's start there. It's a thing that you dip with. We would call them like a ladle. You know, those big like spoons that have the almost like a bowl at the bottom of them to scoop up soup. No. Okay, then help your parents cook more often. Dipper is the same idea. They would dip it into like a bucket of water to get water from they have a bucket from a well and then they dip their ladle in it to get water. They called it a dipper. So the Big Dipper looks like this. And can you see the ladle shape? Here's the handle. Here's the bowl part of the Big Dipper is pretty easy. It takes up a big portion of the sky. A lot of people can find the Big Dipper. Well, how does this help you find the North Star? Because there are two stars in the Big Dipper called the pointer stars. The pointer stars are these two stars in the bowl of the Big Dipper. And what do you think they point at? They point directly to Polaris, which is the North Star. Why am I telling you this? One, so Sarah knows how to find her way out of the woods. That's one reason. The second reason is this is part of the stuff you need to know about the North Star. This has been on the Regents before. How do you find the North Star? You find the two pointer stars in the Big Dipper, and they point to the Little Dipper's handle. And that first star in the handle is the North Star. So yes, you need to know this. So if you haven't already, do exactly what I did here. Take the two pointer stars, point them to Polaris, which I believe I circled for you. You need to know how to do that. Again, why do you need to know how to do this? Because you also need to know this part right here, that the altitude of Polaris is equal to your latitude. I'm telling you guys, I have taught earth science for 14 years. There are 3 Regents exams every year. And on every single Regents I have ever seen, this is a question. Definitely something you must know for the Regents is that altitude of Polaris equals your latitude. I like to abbreviate that, and I'm not kidding, you need to know this. Alt equals lat. So altitude of Polaris equals your latitude. So one thing we haven't talked about is what is altitude then? Does anybody know what altitude is? Do you know that? It's how far up you are. So if you've ever been in an airplane, you might hear them say, we have now reached a cruising altitude of, and then they tell you how high up off the ground you are. Well, we're now going to measure that in degrees. Not degrees like Celsius or Fahrenheit, but degrees like angles like you do in math class. Don't worry, this isn't fancy math. Nice and simple math. Do you guys know what the angle would be if I was standing here on the ground? So that's like the bottom part of my angle. And I looked straight up. Do you know what that angle is? That's a 90-degree angle. So you do need what? It's perpendicular, which makes a 90-degree angle. So if I look straight up and I'm like, hey, there's Polaris. That means Polaris is 90 degrees above me. And since, what do we know? I know my altitude of Polaris, it's 90 degrees. What else do I know? My latitude is 90 degrees. So if I can see Polaris and it's 90 degrees above my head, which means my latitude is 90. Where am I? The North Pole. Good job. The other angle you'll have to know is if I happen to look out and Polaris was right here. What angle is that? Right here. Right here. So if I'm standing here and I look and Polaris is right there, 0. That's a 0-degree angle. You need to know that. And then the other thing that you should be able to do with this angle stuff is what's this about halfway between 0 and 90? 45. So I know in geometry, they make you know a whole bunch of other stuff and use a protractor to actually measure these. We're not getting that fancy. As long as you know straight up 90, straight out 0, halfway is 45. And then they might say something like, if you're way down here, and they might just say less than 45, and here a little bit greater than 45. They won't make you know anything fancy with angles. As long as you know 90, 0, and 45, you're good. So this is super helpful. This is helpful if people don't have an actual compass, or if they were escaping from slavery or pirates out on the open waters. They would just look to find Polaris, see how high Polaris was, and voila, they know their latitude. Longitude is a little bit trickier to figure out your longitude, and we don't even need to know all the details right yet. But one thing I want to do for the miscellaneous for longitude is same longitude equals same time. I'm just gonna slap up a quick picture here. Here's a picture of the world. Zoom in over here on North America. Which way does longitude go? Up and down. So here's Buffalo right around here. Here's Florida right here. Any of you guys ever been to Disney World? Anybody ever been to Florida? Do you have to change your clocks? No. So what, notice that we pretty much line right up with Florida and New York State? Up and down wise. We're the same-ish longitude, so we have the same time on our clocks. But anybody been to California or somewhere over here? Arizona. I think it's there. I can't quite see. It's a little blurry. Yeah, it's in this general area. Do you have to change your clocks to go to Arizona? Yes, you do. You have to change your clocks to go to California. Is New York and California or Arizona on the same longitude line? They are not. So only time it's the same time as if you're on the same longitude lines. The other bullet that I want to put there is Earth rotates 15 degrees every hour. And that means time zones are 15 degrees apart. All of the stuff that we did on this piece of paper is not really in your reference table. There are a few things that you can get from a reference table, but basically this page you need to know. We will practice it, and you do know most of it already. We're going to skip for now page 8. We are going to do page 9, but before we do that, we're going to focus in on the reference table. grab your reference table and open it up to page 5, please. Page 9 is the homework. I'm hoping to get to some of page 9 right now. So I do want you on page 5 of your reference table. We're going to be writing all over the reference table, so get that out in front of you. If it's in your binder, you're going to need it out because we're going to be using it a lot. If you have too much stuff on your desk, we're going to be done with all the other stuff for a little while if you want to set it aside. You'll need with you now your ruler and your 2 different colored pencils. So to start with, I would like you to put your ruler on this map of the world on a latitude line. So this is my test to see if you know which way latitude goes. So pick any latitude. Look back on your notes on page that we just did in case you forgot. Latitude, how did I say I remember? Latitude, well, that too, but no. Latitude. So that's putting your ruler flat. And what is, where's the equator? In fact, wait, how about this? Put your ruler on the equator. So I did not. I'm now testing you. We're going to just kind of walk around. Make sure you've got your ruler on the equator. Okay, good. We remember the equator. What is the actual number for the equator? 0 degrees latitude. So find 0 on both sides. Line your ruler up beautifully and take one of your colored pencils. And make a beautiful equator going across your paper. So if mine looks crooked, it's because the camera is crooked. My line is perfect from one 0 to the other 0. So from 0 to 0. We're going to go ahead and we're going to label this equator. I'm going to go over here. And now my question for you is, actually, it's not really a question. So latitude measures how far north or south of the equator we are. So north is this way. And south is this way. So we have just broken our map up into the northern hemisphere, anything north of the equator, and the southern hemisphere, anything south of the equator. So let me ask you this, where's Florida? That was the perfect answer. Jeff, do you agree? Okay, so we say here in the United States, no, don't do any other drawings. Only what I've done on the board so far. Put your pens and pencils down if you've done what I've done. So here was my question. We say Florida's in the south, right? But it's in the northern hemisphere. It's south of us, but Florida, which here's North America, Florida is this little guy sticking off right there. It's still north of the equator. So I want you guys to be careful with that. Just because we say it's south of us does not mean it's in the southern hemisphere. So that's a good point. So to do Florida's latitude, and so what we're going to do, I did take for granted that you knew where Florida was, but you don't have to know. It's nothing you have to know off the top of your head. Here's North America. Everybody point to North America. Then go down till you get to this little handle on the eastern coast of North America. It's this little tiny part, right? And you can barely see it on my map. You can see it down here. You just cannot see it on the screen very well. Put a dot on the very tip of Florida, the very southern tip of Florida. If we were to figure out Florida's latitude, And I know some of you are like, why is she taking so long to talk about this? If that's you, please bear with me. The rest of you who are thinking, okay, I'm good with this, good, that's why I'm doing it. When I do latitude and longitude, I make it take me a little bit longer. Here's what I want you to do. Everybody put your ruler back on the equator. Decide if you have to go north or south of the equator to get to Florida. North. So what I'm going to do, and I don't know if you noticed this, this is the first question in your homework. It asks for the latitude and longitude of Florida. I right away, before I even think of a number, label Florida's latitude as degrees north. Because I know sometimes my brain doesn't like to think. So I eliminate thinking by just doing everything bit by bit. Florida has a north latitude. Now I need an actual number. So take your ruler, go north until you hit that dot we just put on Florida. And then follow your ruler over to one of the number, or to the number sides. You'll notice there's numbers on both sides. So whichever one you're more comfortable with reading. I'm going to the right because I'm closer. What do you think Florida's latitude could be? 25 would work. Let me ask you, is it right on the 20 line? Is it right on the 30 line? No, it's about halfway in between. That's where Jeff got the 25. So I go back and I do the 25. Now we got to do longitude. We're going to do the same thing. Now everybody put your pens or pencils down, because every time there's always one person who screws this up. I don't want anybody screwing this up. So pens or pencils all the way down. Right now, before you do anything, take your ruler, put it longitude wise. And I would like you to put your ruler on the prime meridian. Do not draw it yet. A couple of you got it. Let me ask you this. What's the longitude of the prime meridian? Is that what we wrote yesterday? Is that it was? Can you put back to your chart on page, is it 8? 7? Flip your paper to page 7. First thing we wrote about longitude. What is the degrees for the prime meridian? Does it say 180? That doesn't say prime meridian. Prime meridian's right here. Not 0, 0, but just 0. What's the longitude of the prime meridian? 0. Put your ruler on the 0 longitude line. Still don't draw anything. Whew, that's weird, right? Where's zeros? Way over here. So what I want you to do, once you've found the real 0, 0, because it's in a weird spot, I want you to connect the 0 on the top to the 0 on the bottom. Yes, good question. I would use a different color. I am also going to label that one prime meridian. Why was that? Why did so many of you not have your ruler there? What's so weird about this particular map? We are used to seeing maps, and I have a picture of one right here. It's just a regular map. This is the one I was just using a few seconds ago. We are used to looking at the prime meridian going down the dead smack center of a map. What else are we used to seeing? Where's North America on this map on the board? All the way to the left. Look at your map on your reference table. It's on the right. So did the makers of your map on your reference table, did they just change the world? No. They just shifted the map. So basically, we're used to looking at a map. It's basically when they take a picture of the map, when the world is like this, with the prime meridian going down the center, North America on one side, on the left, and the rest of the world on the right. Well, now all they did is they made it so that the prime meridian's off to one side. They basically just took a picture when the map was in a different spot. Why did they do this? They did it to mess with your heads. Not gonna lie, they're big jerk faces. They just want to make sure you're able to still work a map when it's not the same map you're used to. So the same is true. Remember, the longitude measures how far east or west of the prime meridian we are. So it still works the same way. This way, this little section here is going to be east of the prime meridian. Oh, by the way, how do I know that's east? Because remember this little guy here, never eat soggy worms. Still works. No, it's worms. We won't argue. It's worms, my class. I can eat soggy waffles. There's no way I'm eating soggy worms. Okay, anyway, so it still works the same way. You take the prime meridian and you go east of it and you're east. So does that mean that's all that's east is that little section? No, guys, remember the world's a circle or an oblate sphere officially. This line right here that's labeled 20, notice it's the same line over here that's labeled 20. So from 20 over to 180, this is all east. How does it what? Okay, so again, so remember it's a circle. So this page 20 here really matches up with the 20 on the other side, making that all east. Then from the prime meridian, west, this is all going to be west. So I also labeled that. No, we're not done. Let's do Florida's longitude. So we already put the dot for Florida. So first of all, did you guys do all the labeling I just did? Same idea. Before we put our ruler on the equator, now I want to put the ruler on the prime meridian. Decide now, are we going to go east to get to Florida or are we going to go west to get to Florida? West. So same deal. So I don't have to think about it later. I go to my homework and I put degrees west for Florida's longitude. And then I slide west until I get to Florida. And it's almost 80, right? Depending on where you put the dot, it might have even been 80. But Sarah's right, it was a little bit before 80, so I'm going to go with 79 degrees west. Everything else is labeled on this map except for Buffalo. Take a look at your world map. Do you have any idea where Buffalo is? So let's first start. What continent is Buffalo on? North America. Where in North America are we? We're near the top-ish, but not very top. That's Canada. Is there anything on this map that might help you find Buffalo? The lakes. So we've got, I'm not sure how familiar you are with the Great Lakes, but we've got the three bigger guys, Superior, Michigan, and Huron over here. The two little guys are Lake Erie and Lake Ontario. Everybody see the two littler lakes? Basically where they touch. It's not exactly Buffalo, but basically close enough. That's Western New York at least. So where the two little lakes touch. You got the three bigger ones up here and then the two littler guys there. Where they're touching is Buffalo. Put a dot there. Everything else is labeled. Your homework is just the chart on page 9. So this is your homework. Not questions 1 through 5 at the bottom, just the chart on the top using your reference table. Also remember, you guys have your test corrections. If you want to do those and get your 10 extra bonus points or even more, you have to do the test corrections and retake by next Tuesday.